right? So, right, from diodes and tubes to transistors, and then integration in electronics to smaller and smaller and smaller sizes, to microprocessors which can have hundreds of thousands of small transistors inside them. Okay. Here we are showing you a much bigger thing. You see, this is a General Motors factory. General Motors, even in 1994, for a lot of the precision welding, robots are being used. Robots. Now these are completely electronically controlled, right? There is no human being inside there and so on. All the materials, all the engineering, all the manufacturing is going on by robots. So there is a huge thing. So this is not one machine. The whole factory is electronic in nature, right? So electronics can go from a very small product to the whole thing like a factory, electronics. And here, of course, we are showing you lots of different electronic chips, right? Chips and transistors, the whole circuit boards, these are solar cells and so on. So in all of them, there is a lot of electronics involved. But the brilliant thing is that only two metals, silicon and germanium only to a little extent. Majority, 80 to 90% of all electronic transistors and circuit boards and these and chips are made of silicon, right? But there is about 2 times silicon in the earth as compared to iron. So the future of engineering is safe. There is no issue about material availability of electronic products there, right? Another type of material which is not basic, right? Electronic materials, we were saying it is based on the application, right? The materials which are used in electronic industry. Now, nanomaterials are not based on application even. They are based on the method of production. How do you produce the material? Whether the material is a metal or a polymer or a ceramic, the way you produce it, right? So here we are saying it is not a material type based on its nature, but characterized by processing, manufacturing process, right? You don't read below. If you like, you stop here, pause here, and tell me what do you understand by the word nanotechnology. Nanotechnology. This is the most modern word around in the world of engineering for the last 10, 15, 20, 30 years. What do you think is nanotechnology? Tell me what is nano, just nano. No nanotechnology, just nano. What is it? Right? It is just a scale, you know, right? In powers of 10, if you go up, 10 raised to 3 is 1000, 10 raised to 6 is million, 10 raised to 9 is billion, right? So you have mega and so on. But if you go 10 raised to minus 3, it is milli. 10 raised to minus 6 is what? Micro. 10 raised to minus 9 is what? Yes, nano. 10 raised to minus 9 is nano. So 10 raised to minus 9 meter is a nanometer. Right? 10 raised to minus 9 meter is a nanometer. So nanotechnology now should be what? Now you understand that nano means 10 raised to minus 9. So what is nanotechnology? Yes, so if you have guessed, if you do any technology, any manufacturing, any engineering, which involves very, very small size, the size of a nanometer, 1 billionth of a meter. You break a meter into a 1 billion pieces. So when you go to that small size in manufacturing or technology, then the whole technology is nanotechnology, right? Similarly, nanomaterials are materials that are produced on the nanoscale. You can have a metal, you could produce it normally, but now if you use nanotechnology to produce this material, meaning that during manufacturing you will use particles of 10, 20, 30, 100, 200 nanometer size, then you will say this is a nanomaterial, right? So this is it. So we are saying that nanotechnology, designing and producing objects or structures at a very small scale, 100 nanometers or less. Nanomaterials, main product of nanotechnologies. nanoscale particles, tubes, rods, fibers, smaller than 100 nanometers in at least one dimension. Right? So, nanotechnology is the engineering where we produce at very small particle size, and nanomaterials are the materials that you produce by using nanotechnology. And they could be any of the earlier materials. A metal can be produced as a nanomaterial. A polymer can be produced as a nanomaterial. Now, what is the most common use now? Healthcare, electronics, cosmetics, textiles, information technology, environmental protection. Almost everywhere we use nanomaterials now, but mostly in healthcare and sometimes in electronics and so on. Now, properties of nanomaterials are not very well characterized. The problem is that when you produce a material by a standard method, then you exactly know how the properties will be. But nanotechnology is brand new. And at what size of nano? Were you using particles of 50 nanometers and then started making a product? Were you started using 100 nanometers and then started it? The properties will change. When we go to the next chapter, which we will start, properties of materials, I told you, then we will see that there is a big relationship between the size of the particles and the property of the material. If the size of the material changes, same material, it is the same, exactly same as steel. But if it is made of larger particles or if it is made of very small particles, the properties will change, right? So we have already told you earlier when we were talking of metals that there is a technology called powder metallurgy, where we do not produce a component in a traditional way by casting or extrusion or forging, but we crush the metal into very small fine powder, and then from that powder we make. So that is not nano engineering. Those particles you can see, but it is already very small particle size, and nano is extremely small particle size. So here we are showing you some huge nanotechnology shapes. This type of ball, like a football, but particles, nano-sized particles. So when we do nano engineering, nanotechnology using this as the basic shape, then it is called a fullerene. When we make these long tubes, then NT, nanotube. So this is also a nanotube, this is also a nanotube, and so on. So when you use a tube type, right, small particles arranged in a tube form, and this CNT is carbon nanotube, right? And then if you make it a flat surface like this or this, then it is called graphene. So for you at this level, if you know these words, fullerene, nanotube and graphene, then these are the three basic geometry in which nanomaterials are used and nanotechnology is carried out, right? So we don't want to go more into this, but this means that you will already be talking like a learned person in the field of modern materials if you can say that, you see, if you do nanotechnology or if you use nanomaterials, produce nanomaterials, then the three basic shapes in which you do this type of technology is that the nanoparticles, you arrange them in a spherical pattern called a fullerene, or you arrange them in a cylindrical format shape called a nanotube, or you do it in a flat sheet type where you call it graphene. And then from these three types of materials, you do your engineering of nanotechnology type. Here we are just showing you, right, that graphene based nanomaterial with magnetic properties, right? This is very, very strange. It is called ferromagnetic graphene. So now this is important. We told you ferrous materials, non-ferrous materials, and the main property of ferrous materials was that they can be given magnetism, they can be changed into electromagnets and so on. So now at the graphene level, we are doing nanotechnology, but even here we can make magnetized materials. So this is huge. Then we can go forth and so forth. Here we are showing you carbon nanotube. carbon nanotube, giving you an example, right? So new nanomaterial can allow electric vehicles. You know, in the last 10, 15 years, electric vehicles have really come up to travel farther. The problem with electrical vehicles was that you have to charge them, and say after riding 50 kilometers, if the charge is finished, then you have to recharge them. So the problem used to be that they are very nice, there is no emission of carbon dioxide and so on. But if they do not run for more than 50 kilometers in one charge, then you have to have a lot of charging stations all over the city. So they discovered, this was discovered almost 20 years ago, this is not new, that using nanomaterials, they can do something so that they don't have to be charged so often. So rather than 50 kilometers, they can go to 100 kilometers, 200 kilometers, 300 kilometers, like in a normal petrol car, right? So a powdery nanomaterial is used to extend the lifespan of lithium sulfur batteries, which are used in electric vehicles. Could increase the driving range of electric. So this has already happened. By the time this slide was there about 10 years ago in your book and so on, we are saying that this could increase the driving range. Now you already know that Tesla and so on and all the other companies, Tesla is the main founder of electric vehicles. It is a California based company in the US. But once they developed their electric vehicles to a very larger scale, then all the other companies like Honda and BMW and so on have also started going to electric vehicles now. So now, of course, this nano material has been added to the lithium batteries that were used in electric cars, and they have increased the life of the battery to much more, twice and thrice and so on. So this is one of the most modern uses of nanotechnology. A new type of material, again not based on the nature of the material, but sort of where it will be used, right? Application. So just look at the word biomaterials. Don't read further. Stop for a moment, pause, and you tell me, biomaterial. Bio, of course, is something biological. So what is biomaterial? Is your finger made of a biomaterial? Are your bones made of biomaterials? Are your teeth made of biomaterials? Yes or no? Yes or no? What is organic materials? All the materials that are there in human and animal bodies and plants, those are called organic materials. So the material for my skin and my bone and my teeth and so on is basically organic material. So what is biomaterial? Anybody? Right? Again, don't read below. You can always read below very quickly and you can answer me or not. But if you challenge yourself, then you are thinking. And when you study anything with your mind open and thinking, right, challenging yourself, then you understand much more. So, okay, maybe some of you have answered correctly. You see, natural biological materials are not biomaterials. Natural biological materials are not biomaterials. But if I introduce an artificial material which can be used inside my biology, right? For example, you go to your dentist, a tooth was broken, he builds up this tooth by an artificial material which is not inside my body. But after he builds it up, you cannot tell the difference between the normal tooth and the new engineered tooth. So this new material which is used inside the human being, so it is used like a biological material, but it is artificial. This is now a biomaterial.